Hey gang, today we're going to be simplifying non-perfect square roots. To simplify a non-perfect square root, first determine the largest perfect square factor of the radicand. To do this, you're going to use your calculator to find factors of the number. You're going to choose y equals and put in the given number divided by x. Then pull up a table. The table will list all factor pairs of the given number. Look for the largest perfect square factor that occurs. Second, you're going to rewrite the radicand as the product of the two numbers found. Third, you're going to take the square root of the perfect square and move it outside the radical. Leave the non-perfect square factor as the new radicand. To do this well, you must know your perfect squares. Find the square root of the following perfect squares. So underneath you have a list of all perfect squares. I want you to take the square root of them and then practice those on your own. It is really important that you're able to see a number and know whether it is a perfect square or not. I think you guys all know that 9, for example, is a perfect square because 3 times 3 makes 9, and 25 is a perfect square because 5 times 5 makes 25, and 100 is a perfect square because 10 times 10 makes 100. But really, I want you to be able to recognize all perfect squares up to like 400. 400 is a perfect square because 20 times 20 makes 400. So take a second and work on those and then come back to the video. All right, so here's some easier examples that we don't necessarily need a calculator for, but I'll show you when we do how you would do that. So what is another way to write the square root of 20? So in my head right away, I know that 20 is 4 times 5, and 4 is a perfect square, 5 is prime. So those are my two factors that I need to use in this case. So square root of 20 is equivalent to square root of 4 times 5. Then, since 4 is a perfect square, I can take its square root, and the square root of 4 is 2. So that comes outside the radical, and 5 becomes our new radicand. So 2 radical 5 is our answer. Now, if I'm not 100% sure, I can check my work. If I do square root 20, I get 4.472135955, and that would keep on going if my calculator screen was longer. And if I do 2 times the square root of 5, I get the exact same number. So I know I have equivalent answers and that this is the correct simplified version of square root of 20. It's also important to make sure the number under the radical is a number that doesn't have a perfect square factor. 5 is prime. Its only factors are 1 and 5. Neither one of those are perfect squares. So we have gotten to the most simplified version of the answer. Then for number 2, what's another way of writing the square root of 54? Well, 54 has a factor of 9, which is a perfect square, and it's 9 times 6. Then, although 6 is not prime, its only factors are 6 times 1 or 3 times 2, and none of those are perfect square numbers. So we're at as simple as we're going to be able to get with 9. Then the square root of 9 is 3, so I can take that outside the radical, and I leave the 6. And again, I could check my answer if I wanted to. If I do square root 54, I get 7.3484692228. And if I do 3 times the square root of 6, I get that same exact answer, which means I most likely did it the correct way. Again, the only way that would be wrong is if it's not as further simplified as possible. So again, we know the 6 is as simplified as possible because it doesn't have a perfect square factor. All right, so let's see what we have next. Number 3, we have square root of 50. Now, 50's got a lot of factors, so I could go into my table by going to y equals, clearing what's there, and do 50 divided by x, and then pull up the table. And all of these are going to be factors of 50. So 1 times 50 makes 50, 2 times 25 makes 50, 4 times 12 and a half makes 50, 5 times 10 makes 50. We only really want to have whole number answers here when we're simplifying here. 10 times 5 again makes 50. So at the top, I actually saw a perfect square, and you might have recognized it right away with 2 and 25. So 25 is our largest perfect square factor of 50. So we can write this as square root of 25 times 2. Square root of 25 is 5, and square root of 2 is left over. Okay. Same thing with number 4. If you weren't sure of what the greatest perfect square factor is here, you could pull up your table, change your 50 to 48, And here I have 1 and 48, 2 and 24, 3 and 16. And here, 16 is a perfect square and is the largest perfect square factor that shows up. If we went to 4 and 12, yes, 4 is a perfect square, but it's not the largest perfect square factor. So we're going to use 3 and 16. So we do square root of 16 times 3. 16 is my perfect square. I take its square root, I get 4. Square root, radical 3. So that is our final answer. You're going to try 5 and 8 on your own. These are simpler ones, and then we'll start some more challenging ones. Okay, so for number 9, now we have a larger number. So again, we go into our calculator, square root, change whatever number you have in there to 128 divided by x. We get a list of factors. So 1 and 128, neither of which are perfect squares, but then 2 and 64. And right away, we should recognize 64 as being a perfect square factor. So we write square root 64 times 2. 64 is our perfect square. Take its square root, we get 8 square root 2. Simplified answer. Same thing with number 10. Y equals, change that number to 144. Oh, not 144. Freudian slip there. Hopefully you didn't catch it. 288, second graph. So 1 times 288 are factors of 288. 2 and 144 are factors of 288. And right away, I recognize that 144 is a perfect square. There's my Freudian slip. I had that in my head before. That's why I said it out loud. Okay, so I change this to square root 144 times 2. 144 is a perfect square. Its square root is 12. So my simplified answer is 12 square root 2, or 12 radical 2. All right, let's keep going. So for number 11, we pull up our table again, change it to 108, and we get 1 and 108, neither are perfect squares. 2 and 54, neither are perfect squares. 3 and 36, 36 is my perfect square, so we're going to use that value there. So we have square root 36 times 3. 36 is a perfect square. Square root of 36 is 6, so it's equivalent to 6 radical 3. Then 250, same thing. Pull up our table, change the number to 250. And 1 and 250 are factors. 2 and 125 are factors. Skip to whole numbers. 5 and 50 are factors. And 10 and 25 are factors. And I recognize 25 right away as being a perfect square. So that's going to be my largest set. Square root 25 times 10, which you actually see right in the number. Square root of 25 is 5, and we leave the 10. And again, 10 I know is as simple as I can get because 10's factors are only 1 and 10 and 2 and 5, and neither of those are perfect squares. So that's as simple as it's going to get. All right, so you're going to try 13 through 16 on your own. I will be around to help you out. Make sure you're checking in with me before moving on to your exit ticket.